All right, cool. Welcome back. Questions on PA2? Lots of people joining. That's cool. I got PA1 graded, but I have to put the grades in still. But it looks really good, right? If your program compiled and your functions worked, you probably got 100, and there were a lot of hundreds given out. So that's awesome. And hopefully PA2 is treating you well. All right, well, let's start digging into some details. I did this briefly before talking about scanners and stuff, but I want to go into much more information about this. So PA2, right, you need to read from a file. And so there's two things that you're going to use. The first is the scanner class, which we've touched on before. Scanner is sort of like Java's version of scanf. It's a way to read from somewhere and break the input up on different characteristics. So you can read an entire line at a time. You can read a single word at a time. You can parse with regular expressions and all kinds of things. When you construct a scanner, you tell it what to scan from. And the way we did this initially was we just constructed with an argument of system.in. That's basically standard in. So it reads from the keyboard typically and processes accordingly. But to read from a file, we're going to construct the scanner with what's called a file object, right? So an object of type file. And so let's take a look at the file class. Java.io.file, and you construct this with a path name. So path name is either a file name or a full path ending with a file name. And it just returns an object of type file. We don't really need to do anything with that, but we can. For example, you can tell whether or not the file that you constructed is executable, readable, writable, and so on and so forth. Now, constructing a file object does not actually do anything to the file. It does not open it, and so on. It's basically creating a reference or a handle to the file. And then you can use various methods to do things like, delete it and so on and so forth. And so when we construct a file, even if the file doesn't exist, we're not going to get any errors, right? In fact, file has a method you can call to say, does it exist? But when we pass the file to the scanners constructor, we have the potential to get an error. So let's go ahead and run some code. And let's see what we got in here. With all of that, I don't have a main. Okay, so make a main. So we need to do some imports. So there's our scanner. And there's our file. By the way, a few people imported things like string in their PA1. A lot of these things like strings are already available for us. They're already imported, right? Import is really it's adjusting the namespace. It's not actually pulling in everything from file, but it's letting us know that when we talk about the class file, it should look in java.io. We could import java.io.asterisk, and then when we looked for a class, if it didn't find it, it would look in java.io for that class. That's my working understanding of import statements, at least. All right, so I'm reading chat messages on the side here. All right, so let's go ahead and make a file. So yeah, someone's asking if it's okay to do an import java.utility.star instead of scanner. It's better not to. If you have a lot of things that you're going to use from utility, yeah, you can do that. But it's probably better to be a little more tactical about your imports. Just kind of a general habit. But you know, it's not going to break anything, and I'm not going to take off points for that. But you know, anything that helps you get more familiar with the classes you're working with is probably good for the course and for down the road. All right, so let's construct a file, and then let's construct a scanner. And yeah, someone just pointed out, if you do an import with an asterisk in it, you have the potential to end up overriding classes, right? If two packages have a class with the same name, then you might get a conflict, right? So being very precise in what you want to import is probably your best strategy there. So I'm going to construct a scanner, and I'm going to construct with an argument of my file. So we're going to read from testfile.txt in this case. So when I compile that, I get this error saying unreported exception, FileNotFoundException must be caught or declared to be thrown. Okay, so this is warning me that scanners can throw an exception. They can report an error condition. And there's a few ways to deal with that. And the easy way to deal with it, which I don't want you to do, is just say that your main method can throw an exception. If you do that, you have to import that FileNotFoundException. And so if you look at the scanner documentation, you can look at the FileNotFoundException, and it comes from java.io. And so you can go ahead and import that. Typo City here. Alright. And then we run Java main. It works fine in this case. Now, if we tried to open a file that didn't exist, then when we run this, we get an exception, right? Java IO FileNotFoundException trying to open test file. No such file or directory. Okay. This is a fairly painless way to get your code to compile, but it's not a good way in this class to handle exceptions, because if you do this in your code, right, and somebody calls process file, it's going to, you know, spew all of this on your screen, and we don't want that. Okay, we don't want to generate error messages from these other classes' methods. We want to write our own error messages or handle them in our own way. For example, in process file, we just want to return false. We don't want the user to have to see any of this stuff. So I don't want you to declare your methods as throwing exceptions. Okay, what you want to do is use a TryCatch block. And TryCatch blocks are just another you know, type of block enclosed in curly brackets. We're used to those. And they have the following setup. Basically, you can say try, curly bracket, bunch of stuff, close curly bracket, and then you can say catch, curly bracket, bunch of stuff, close curly bracket. Okay, so what happens? You have statements in this try block. If those statements execute without throwing any exceptions, everything is good. it skips the catch block, it comes down to here and continues executing. Okay, so it's just putting brackets around your code, but it doesn't affect anything. But if something goes wrong, you execute the first statement, you execute the second statement. If that statement throws an exception, your code jumps down to the beginning of your catch block, and now it executes whatever is inside here. And then when that's done, it continues with what's outside the TryCatch block. So the drill is, if you're going to execute some statements that can potentially cause an exception, put them inside a try, and then put a corresponding catch to go with it. And if anything goes wrong here, you'll jump down to your catch. Okay, so some details. Number one, keep these blocks as small as possible. Anytime you're writing code that can throw an exception, right, you could just put your entire method in a try block. Okay, that makes it easy to write your code, but it's really not what you want. Okay, really, if these three statements can cause an exception, put them in that block. If only one of them can, just put one statement in here. Okay, make your try blocks as tight as possible. This will help you with debugging, it will help you with modifying your code and maintaining it, and so on and so forth. So keep your try blocks very, very, very tight. The catch block begins with the keyword catch, but we have to put something in parentheses here. Okay, so what we put in here is two things. We put an exception type, and then we put an object. And we can think of this kind of like calling this as a function, right? But it's not really calling a function. But when an exception occurs, if it's an exception of this type, then this object will be assigned information about the exception, and we can use that object inside here. All right, so let me just put some code in here. So it's the call to scanner that can cause the problem, right? So it's complaining about line 13 when we make the scanner. So let's put a try block around here. Try. Alright, so there's my catch block. And let me just, yeah, I knew I wouldn't get that right. Third time's a charm. There we go. Okay, so so we're going to try to execute this statement in a try block. If it throws an exception of type FileNotFoundException, it will see this catch block with an exception type of FileNotFoundException, right? And except will be given information about that exception. Okay, so you can really think of this as a function, right? Takes an argument named except of type FileNotFoundException, and if a FileNotFoundException occurs in here, it's going to look for a catch block that takes an argument of that type. Okay, and if that happens, except will be an object we can use to figure out what went wrong. So FileNotFoundException, right? It's a class like everything, which means except has methods available to it. Okay, it has all of these methods. Now these aren't methods defined on this page, but a FileNotFoundException is an extension of an IOException, exception throwable, right? And the throwable class that it extends defines all of these. So for example, we can say PrintStackTrace, right? And PrintStackTrace will print out information about where this error came from. Okay, so let's just stick with code here. Let's put something in here. So let's just print out an error message, and let's return from here. And if we come out of the TryCatch block, we'll print a message saying that we opened the scanner. And then we won't do anything in particular. All right, so compile this up, try to run it, and it tells us something went wrong opening the scanner. Goodbye. And if we try to open a file that does exist, it tells us file opened successfully. So we have very, very clean, very controlled handling of exceptions now. Okay, we don't have this big mess coming up on our screen, but we can get to all this information if we want, and we can actually make this appear if we want. So for example, in here, let me go back to a bad file. Something went wrong opening the scanner. Goodbye. Right, so let's print out, here's a stack trace. And let's use this PrintStackTrace method of except, right? Except is an object of type FileNotFoundException. And so we can call that. So something went wrong. Well, first it tells us something went wrong. Here's a stack trace. It prints out the stack trace, and then it says goodbye for real now. So if we like, the segfault message that we normally see, we can still print that out. But we don't have to exit at this point. We could do something else. We could ask the user for a new file name. We could do something totally different. It's totally up to us. So this gives us a great deal of control over exception handling. All right, so that's the right way to use TryCatch blocks. So let me start showing you some of the realities. Okay, FileNotFoundException is the exact exception we're looking for, but usually, at least for me, I'm only going to have one possible exception around a line of code. So you can use a more general exception than the one that you're actually looking for. And the most general exception is just exception. Okay, so this will work, and I'm okay with your doing this. So I can say catch any exception that occurs, right? Make except an object that has that information in it, and then go ahead and do our processing. Now, if there were 5 different types of exceptions that could happen, you could have a separate catch block, separate catch statement for each possible type of exception, and it lets you, do more nuanced control. File does not exist, file is not readable, and so on. But exception is a catch-all. So if we do that, right, it still works exactly the same as we expected. All right, so let's go back to this. And a lot of things can throw exceptions, okay? And for any exception that can occur, you can make a catch statement, right, if you're in a TryCatch block, to try to pick up that exception. So when you're looking at the documentation, right, you can see these possibilities. And there are a few exceptions that you don't have to catch. They will just throw exceptions to your screen. But mostly, if there's a chance of something going wrong, make yourself a TryCatch block. All right. So with all of that in our bag of tricks, we can refer to a file by constructing a file object. We can pass that to a scanner, and that lets us open a file. So let's start playing with a file. And the next thing we're going to notice is if I try to do this, so let's read in from our file one line at a time. And if I try to do that, I'm going to get a compile error. Not the one I was expecting. Okay, I'm going to get a compile error on this variable sc. Okay, and it's saying it cannot find the symbol sc. Well, you know, I constructed sc up here. It's an object of type scanner. This happens a lot when you put something inside a TryCatch block, right? Any objects that you declare inside the TryCatch block are local to the TryCatch block. So inside these curly brackets, I can use sc. It's an object of type scanner, but once I leave this block, sc does not exist. Okay, and this happens all the time. This happens when you're in an IDE and you move something inside a block, and suddenly your variables disappear. Okay, you're changing the scoping of sc. So easiest way to handle that, just declare it outside of your block. And so don't also declare it inside, because if I do that, this is a new version of sc, which is still going to be local. Okay, so declare it up here and then construct it wherever you want. Constructing it inside a block doesn't change the fact that this is the object being constructed, so I can get to this object down here outside of the block. And that should compile just fine. Alright, so we've got an object of type scanner. We're constructing it. If anything goes wrong, we will return. I'm going to get rid of the stack trace because I don't feel like stack traces today. So if anything goes wrong, we'll just print out a nice error message and exit. But if we succeed, we'll come down here, we'll say we open the file, and we're going to go into a loop which says, well, our scanner has another line, let's read it into this string temp and let's print it out. Okay, so we can go ahead and run that, and there's the contents of our test file. Okay, so it reads it in line by line, and we're good to go. All right, let's play with strings and let's play with scanners a little more. So we can read in each line of the file. So there's our test file that we're reading, right? 5 lines. So let's take a look at strings. So a really useful method in the string class is called split. And you don't need to use this for your programming assignment PA2, but it's a useful method to know about. So split will basically take a string and break it up into words for you. So I could say split, for example, around a space, and if my string has multiple words separated by spaces, it will chunk it up into pieces for me. And it returns an array. Now we haven't talked too much about arrays yet, except that in our main programs we have string bracket bracket. That's an array. So So we don't have to declare arrays yet, but let's just go ahead and play with splits. So, and let me make my test file a little more interesting. We'll put an empty line in there too. All right, so let's read this first line in. So temp is the next line from our file. And split this into words. All right, so I'm asking it to split around spaces and store the words into this array called words. So let me print out our line up front first. So next line is such and such, and let's split it into words. And now let's play with this array. Alright, so remember, when you have an array, you can find the length of the array by saying array name dot and the word length. Length is a field. It's not a method. We're not calling length paren like we do to find the length of a string. We're asking for how many things are in this array. This is the magic thing that's missing from C arrays, right? C arrays don't have an inherent length. Java arrays do. So words is an array of strings. We don't know how big it is because it's being constructed by this split method, but we can find the length of it by looking at words.length. So let's just go ahead and run that. Right? And so it says, you know, it opened, hello, this is a test of a very long line, and the number of words was 10. This is fun, 3 words. Well, goodbye for now, 4 words. Empty string, number of words 1. That's kind of interesting. Typos are everywhere. 3, bye is 1. All right, so let's look at the words. So let's iterate over all the elements in the array. This is why spaces are helpful for readability, but I'm not putting spaces in here. So I'm going to print out word bracket, and I'm going to print the value of I, close bracket equals, angle bracket, I'll print out the value of the word at that position, and then I'll put in a closing angle bracket. And let's just go ahead and put some space in here. Alright, so hello, this is a test of a very long line, 10 words, and there's the words. Nothing really surprising here, right? The only slightly odd thing is if you have an empty line and you split it, you get a single word, which is just an empty line. Alright? Because an empty line is not the same as null. It's not like it doesn't exist. It exists, it just has no characters in it. It has a length of 0. But it's a perfectly good string. Alright, and then bye has a single word, and so that's bye. And split is really powerful, right? So I'm splitting around spaces, but I could, for example, split around the letter E. I don't know why I would do that. But if I did, I get something different now. So this is a test of a very long line. Well, my first word was H. E was a thing that split up the H from the next word, which was LO. This is a T, right? That's my second word. And then the E splits from the third word, which is ST of a V. last word is Rai Long Lin, and it ended with an E. If there was no E anywhere in here, right, we get back just the word itself. And if the string ends without a delimiter, right, your last word is just everything from the last delimiter to the end of the string. So the space for now was the last word in this array. So split is powerful, and in fact, split actually takes a regular expression. Okay, so all the regex stuff from 224, right, you can put in here. If you have a more complex pattern that you want to split around, you can do that. Again, there's no need to do this for programming assignment 2, because you can actually ask the scanner to give you one word at a time by just saying next and has next. Okay, but for other things, right, it might be useful to be able to manipulate strings. So we're just playing around with this right now. Alright, so we can split input, we can do next line, we can also do next. So let me go ahead and make a new version. So this is probably more what you want to do in PA2, right? While the scanner dot has next, go ahead and read the next thing from the file. And that temp that we read should be the next word separated by space. Right, so now it's breaking up our input by words. Right? So don't try to read a whole line. Reading a whole line and breaking it up yourself for PA2 is going to be a lot of work, because you start off by reading a line, you break it into words, and you have to remember which word you're going to process, and it sort of interferes with modularizing things, right? Next and has next are nice functions because you call them and they come back with a word. You call them, they come back with a word. You call them and you're at the end of a line, it reads the next line of the file and it comes back with a word. And you don't have to think about, where am I in this line, where am I in this file. You just call next and you get the next word. Okay? And so whatever I want to do, right, I can put in here, and this is just give me the next word from our file. So let's look at each character. So let's look at temp.characterAt I. There's going to be a lot of output, but we're going to take the word and we're going to break it up into characters like this. Okay, so just to practice with charAt, which sometimes trips people up. Right, so if we're reading the word everywhere, it's got 10 characters, right? Characters 0 through 9, and we can just pull off each character like that. And again, those are part of the string class. So string has this method called CharacterAt, and you give it an index and it returns the character. Right? So here's an example where we can throw an exception. if we give it an index which is negative or bigger than or equal to the length of the string, that's an out-of-bound index and we'll get an exception. It does not force us to put this in a try-catch block though, right? Because this is a very, very common kind of exception. So when what I said earlier, there's some exceptions that you don't have to put in a try-catch block, right? This is an example of them. But if you think that you might run into this problem, you could put it in a try-catch block, okay? The issue with try-catch is it invites sort of lazy programming, and that's not necessarily good. But let's try this anyway. Yeah, exactly. You can put the whole thing in a try-catch block and never worry about exceptions again. But you get the frowny face from your teacher for that. So, but you know, that works sometimes, and honestly, sometimes I'm in a rush and I will go ahead and do that. If it's throwaway code, that's fine. But you know, they totally invite sloppiness. So here's a really sloppy way to use a try-catch block. So let's set I equal to 0. And let's print out character I equals characterAt I. Right, and we'll go ahead and increment I. Alright, so this happily works. Our word was hello, it prints out the 5 characters, and then we get this string index out of bounds exception because we did a charAt 5 and there is no character number 5. So we can do this. Right? And no problem. I parsed the whole line, I didn't get any exceptions, and you know, I returned at that point, but I could have gone on to something else in my code. If I wanted, it could have broken out of the while loop and so on. But that's you know, there's no reason for that because we know exactly how far we should iterate. We should iterate up to the length of the word -1. So if you're seeing exceptions, don't immediately go to a try-catch block. Okay? If there's no way to prevent that exception other than putting it in a try-catch block, go for it. For example, someone gives you a file name and you're going to try to open that file. You have no control over whether that file name, you know, is a file that exists or not. Only thing you can do is catch the exception. But, you know, a for loop where you're iterating over an array or something, you can control whether or not you're going to get an exception yourself. So be tactical in your use of these. Unless, you know, it's just your own code. Then go crazy, do whatever you want. Alright, so we've got scanners, we're splitting strings up into pieces, we're splitting words into individual characters. Let's look at scanner a little more. So let me get rid of this stuff. Alright, so we're back to our original one. We're just reading in and printing out words one at a time. So suppose we did this. there again, we run fine until we try to read past the end of the file. And when we called scanner.next, it threw an exception, right? So line 22, right here, said sc.next, that called scanner.next, which noticed that there was nothing left in the file, called the throw method, and it printed out that we have an exception here. So that's why we say, well, SC has something more in the input. Okay, otherwise we'll just keep reading, we'll hit end of file, we get an exception. So remember, Booleans are built in, so we used to do something like this. Right, and that still works. But this does not work. Right? Because it's expecting a Boolean inside the parentheses of a while statement. It's got to be something that evaluates a true or false. And integers cannot be converted to Booleans. In C, they implicitly are, but in Java, this has to actually be a Boolean value. So it can be an expression, or it can be a keyword like true or false. All right. Something else I just remembered I wanted to mention in looking at people's PA1. You notice down here in my main method, I'm using this object called file and this object called scanner, and I have some other objects that I could define. I'm putting those inside my method, okay, not inside my class itself. So I could define file and scanner, or my file and SC right here, and they would be basically global inside the class. And that makes sense if there are multiple methods that need to access that and you don't want to pass it from one method to another. But if it's a local variable to a method, just go ahead and define it inside the method. All right. While we're here, I may as well go ahead and show you my even class. So, blatantly missing comments, embarrassment. Yeah, so I just put this together just so I could write the sample output for the assignment. But yeah, so class even and private int val. Okay, so if you're using variables like inside here, I have a string, in my toString I have a string called result, and I have a string called num, right? Go ahead and define those inside the method that uses them. If I needed to use result somewhere else, go ahead and define it up here so that it's available to everything in the class. For example, the value of the actual integer val needs to be accessed here, and it needs to be accessed here, and so on. So that's a class variable. But the other stuff, keep it as local as possible, right? Just to avoid accidentally stepping on something. And the toString method was the most challenging for most people, and there's lots of ways to do it. This one's pretty explicit. So result is the output string, and I turn my number into a string by just concatenating an empty string to it, right? So num is a string, and I take val. Well, this will call the toString method for this integer, and it will append an empty string. So now num is my string version of the even number, okay? And then basically go through each character, right? Look at the number of characters in that string, get the character at that position, and I passed it to a convert method, which returns the word version of that particular character. And then I just concatenate those to result. So convert, if the character is 0 through 9, it just returns 0 through 9. If it's a dash, it returns negative. And it's got to be one of those because I'm passing it a string version of an integer. And then if I plus 1 is not the length of the string, in other words, if I'm not in my last iteration, I go ahead and append a space to the end of the string. And I didn't check for that, but most people, or a lot of people, handled that in clever ways, which was good. What else did I want to say in here? Oh, so the other approach people took was to take your number and chunkify it into digits by dividing by 10, looking at remainders. Okay, that works as well. It's more work. If you have a number like, 147, the probably most straightforward way is just turn it into a string. There's the first digit, there's the second, there's the third. But you can do 147 divided by 10 equals 14. 147 modulo 10 equals 7. There's your last digit. Now you take the 14 and you do this again. 14 divided by 10 is 1. 14 modulo 10 is 4. There's your second digit. And then you take the 1 and you move it down. 1 divided by 10 is 0. 1 modulo 10 is 1. There's your third digit, starting from the right. And once you got a 0 here, you're done. So some people took that approach, and that's awesome that people who did that got that to work, because that's a lot more complex. Okay, but it's a cool thing to know how to do. But yeah, the string version is pretty cool. And this is what happens when you convert a number to a string. This is what's happening internally, right? That toString method has to do this kind of thing, and it's even more intense when you have a floating, right? When you have a number like, negative 2.5 times 10 to the 17th, converting that into a string, really difficult, right? Well, the toString method does it. So that's available. Yay! Yeah, definitely someone who likes math did that. All right. So that's pretty much all I have to say about files and scanners. I think you're totally good to go now. Theoretically for PA2, those are all the pieces that you need. So let's dig into arrays tomorrow, and then we will go on and we will start building on top of all of this into something else. All right, cool. Have a great afternoon, and I will catch you tomorrow.